Hello everyone and welcome to a new episode of Golang Cafe, and today we're going to talk about JSON encoding in Go. JSON is one of the most known data interchange formats used in the web, and I think you already have heard of JSON or worked with JSON already in other programming languages. And it stands for JavaScript Object Notation, and it's very simple and extensive simple and expressive format for sending and exchanging data and representing data. And we'll see today how we can work with JSON and work with Go specifically using just the Go standard library without using any type of external dependencies or libraries. You will see that it's very easy to do. The first thing that we are going to do is just check the documentation for the JSON encoding package. You can do JSON go doc JSON. You can import the JSON encoding package just by typing import and encoding/JSON, and that will allow you to use a bunch of functions and types that you can use to work with Go to encode and decode JSON. If there is a takeaway that you want to get from today, it's that most of the work that you're gonna do with JSON encoding in Go, JSON encoding and decoding, is around the usage of Marshal function and Unmarshal function. So those are the main two functions that you have to bear in mind when working with Go and JSON. So the Marshal and Unmarshal functions are basically just the functions that you can use to pass any type from Go, and that will then return a byte slice, which is a string representation of the JSON object that you would then use as an output. And consequently, from the other way around, if you want to convert a string that is a straight JSON representation of a Go type and you want to convert that back into your Go type, then you can use the Unmarshal method, which takes your string, JSON string. It takes a pointer to a Go type to which the data is then gonna be decoded into, and returns an error if there was any error. There are also a bunch of other functions. We're gonna touch very briefly on the decoder and encoder functions, which are going to be used when you have a stream of data, specifically when you want to work with when you already have a IO reader and IO writer. I've done already a bunch of episodes around the IO reader and IO writer interface, where you see that you can work with a lot of different scenarios just by using the same interfaces. So this is going to be very relevant if you go check those other episodes. I will link them in the description below. But effectively, the decoder and encoder will allow you to work with JSON encoding and decoding in a more memory efficient way, because it's the decoder and encoder then use a buffered memory, so they are going to be more efficient and not load everything into memory when you instead use the Marshal and Unmarshal functions. If we want to go into the Marshal, and we want to start with the marshalling, with the conversion from Go type into string, into JSON string, then we can just go and check the go doc JSON.marshal documentation, which as we said, it just converts a Go type, which as you can see here in the parameter, it accepts an empty interface, which means accepts any type. So all types in Go implement the empty interface, so you can pass a boolean, string, struct, custom type, anything you want. And what Marshal will do will traverse the value v recursively, which means that if you pass a struct and inside the struct you have further structs, so you have further maps or arrays or other types, then you will recursively go into the struct and into the v values and will attempt to marshal all the contents of this value here. And how does it do that? Well, it uses the Marshal JSON method to produce JSON, and the Marshal JSON method is already specified for each type. So for structs, there is already a Marshal JSON method which the JSON encoder is going to use. And for string, there is also one. For boolean, there is also one already defined, and so on and so forth. So the Marshal JSON method is then used by the package, and more specifically the Marshal interface, which we're gonna see now in a moment as well. As you can imagine, booleans values are encoded as a JSON boolean, so pretty basic floating points or floats, integers, and numbers are also encoded as numbers. Some gotchas to keep in mind are, for example, that if you are going to store HTML code into your string and then converting that back into JSON, then there is already HTML escaping in place, which means that if you write any HTML and you encode that into JSON, that will automatically be converted into escaped rather, using the ampersand notation and Unicode notation here, as you see. So all the HTML brackets are going to be replaced with the proper HTML entities, such that those are not going to be interpreted into the browser. But you can disable that, set escape HTML to false. There's also a bunch of other gotchas around the encoding byte slices. So if you have a slice of bytes, that's going to be encoded into base64 string. And if you have ever worked with binary data and representing binary data in strings, you know that one very efficient, simple way to encode binary data into a string is just to save the hexadecimal representation, the base64 representation of that. So that's what the byte slice encoding will do. So the Marshal JSON on top of the byte slice type will base64 encode and return a string there. For the struct values, it's a bit more complicated. So what happens is that it will go through all the fields and it will then output the JSON string with the key value pair, and the key is going to be the field name, and the value is going to be the value inside the field. And the fields are only going to be saved in the JSON output if they are exported. So if they have uppercase, if they have lowercase, they're not going to be exported unless you specify otherwise. So I have here an example. It's a very simple file. You have a bunch of structs, and this is something that can be similar to some of the examples or some of the work that you can do when working with web services or APIs. You have a bunch of models, and then you want to work with those models in your server, in your API server, and then you want to convert those models into JSON and send them back to the client. And so here we have a user struct which has a bunch of properties, name, age, then a city, which is a struct by itself again. The city struct has a name, GDP, a population, so string and integers. And then the user also has a created at, which is a time.time, and deleted at, which is a time.time, which is a pointer to time. And then we just create the user struct. So let's say that let's pretend that this user struct comes from a database, and we just retrieve our user and our city, attach with the user, and then we marshal. So we use the marshal function that we have just seen in the docs. We pass the user in, and we retrieve the byte slice and the error as an output. And then we just print the output. We convert it to string because otherwise we're going to just see the binary format, just going to see the bytes. And we should see the actual output here. So you can see here, you can see the output already. What I'm going to do, I'm just going to use the JQ, which is a utility for us to see the formatted and predefined format of this. So you have a JSON object as an output, and the keys are the same as the field names in our struct. The values are, as you would expect, the string values, the integer values. The time is a bit curious because the time is being formatted in a way that it's not really readable. It's the default formatting layout, and we can change that. We're going to change that. And also we have deleted that, which is null. Here for some reason it's showing up. It's still showing up null, but it's just it's not looking good in the contrast. But you see that this one is null, has deleted that because we have not set it. So the null pointers, the nil values are going to be shown as null in the actual JSON output. So the first exercise that we want to do is we want to be able to change the name of the fields without changing the name of the struct field. So we want to change the name of the JSON keys without changing the struct names. And the way we can do that is by using struct tags. Struct tags are a feature of Go structs. So in the struct you have the fields, which is all the components of the struct, and then you have field types, string, int, city, time, and pointer to time, and then you have a third parameter, which is the tag section. So the tag section allows you to specify a set of key value pairs. So you can specify key, JSON, and value, the name of the JSON field that you want to give to your field and to your actual JSON struct field. And then you can also have other key value pairs, which we are not going to explore today, but you could also have other key value pairs that are going to be used by other libraries. So each library can actually read its own keys or values in this struct section. You can write any key value pairs in there. So for example, when working with other technologies, or if you work with I don't know, like with the SQL databases or with some other libraries, you could see that you have the possibility to specify a key value, and you can say, okay, for JSON I want to call this field name, for the database, which I call SQL, or I can call it MySQL, depends on the library. And then you can call it username, and so on and so forth. So depending on obviously depending on the library that you're using, the library will tell you what's the key that you are going to be able to use in your structs. For encoding.json, encoded JSON, the key that you can use is understandably is just JSON, and then you can specify the field, the JSON object key that you're gonna see in the output. So now here I'm just gonna use city and the actual names, and now I'm just gonna use snake case, so you will see the difference, because before we had the camel case, and now we're gonna use snake case. So it's just a slightly different formatting and a slightly different thing. And also to notice the difference, we can also here, instead of just name, we can say city name or city GDP. City pop, I can say. So we see the difference there. So the first thing you notice is that names, here you have the uppercase, so here it already changed, the lowercase, age, city. You also have different keys here, city name instead of name, and so on and so forth. You have the created underscore at instead of created at. So you have flexibility around the name of the keys in your JSON objects, and this is one of the very first thing you will learn when you're working with JSON encoding. Another important thing is the ability to exclude one of the fields. So let's say that one of those fields, let's say that GDP is something you just use in your database or in your program, but you don't want to expose to your clients. You still want to keep it in your model, but you don't want it to be shown into the JSON object. So what you do, you just set the JSON field name, just using the minus sign, just using the dash sign, and that will exclude that field from the JSON output. So you see here now that we don't have GDP anymore. That will allow you to remove some of the fields there. There is also one other interesting thing around the output. So if a field is not set, you can decide to remove that field altogether. So for optional fields, for example, you can decide to remove those fields altogether. So for example, deleted that is optional. It's not always present. So what you could say omit empty, just using the comma after the field name and then omit empty, and that will remove the field from the JSON output only if the field is not set. So now we don't have deleted that anymore. But if we were to add deleted that from into our struct, then obviously we need to use a pointer. So if you were to use an actual time, so you have to set the value, that would not be excluded from the output. That's only excluded when you set it as a when the value is not set, then it's going to be excluded from the output. So pretty easy there. If you want to have more fluent schema, if you will. So now one of the other concern was around the formatting of time here, which is pretty difficult to read. So one of the ways that we can adjust the formatting there, it's by defining our own specific type and our own specific marshaller. So something that we have seen is the marshaller interface. So we have seen the Marshal method that it uses the marshaller interface. So the Marshal interface is used by the JSON.Marshal into each type. So it goes into each type, and if the type implements the Marshal interface, then it calls the Marshal JSON method. We already said that basic types already implement this interface by default. So if we were to override the behavior of certain type, we could just define a new type. We define a Marshal method interface method on top of the type, and then we create our custom logic to format the value as we want. So following this logic, what we could do, we could just say, okay, now I want a custom marshaller, a custom formatter for my time type. So I define a new type. You know, I could say custom type, or you can say UI type time, because something is shown into the UI, or it's something that is used. You can actually, I'll just call it custom time because I want to keep it generic. Then you can draw up your own use cases, and then here you just have time.time, custom time. So you have C, and then this implements the Marshal interface. So it's Marshal JSON, and then returns a byte slice and an error. So now we know that each time the JSON.Marshal calls goes through the struct and goes into the custom time, it will call the Marshal JSON, and we'll use the Marshal JSON as a mechanism to transform the time.time or specifically the custom time into a string that is then used as an output in our JSON. So we said we want to format the time in a way that is more readable, and we then want to output it back as a string. The first thing that we are going to do, I'm going to define a layout, which is just a simple layout to format the time. And then what I'm going to do, I'm going to return a byte slice. We want to return a string. We said we want to return a string, and the string is just the time. This is the time, and then it's in between double quotes. So if you think about the JSON string, the JSON values, specifically for the time or for strings, the string are represented in a simple form, and then they are encoded, they are enclosed between double quotes. So we'll have to actually add the double quotes in here using the escaping, so that they are actually printed in the output. And then we can do c.format layout, and then we return nil as an error. So c.format is just a way that we can, if you go check time.format, it's just a way that you can format the time as you prefer. And when we set the time, so this also will change the way that we work with our model. So you will have to do your own changes there, but it's just then it's just a wrapper on top of your own main type. So if you now go back into the formatter, you will see that the created at time is now using the new format layout. So it's just much cleaner and allows us to do the formatting in a more customized way. So the next thing that we're gonna go through, and it's gonna be very quick, is so now this thing here, I want to set it as out.json. So now we have this output saved here. So we want to unmarshal. So let's say that now let's remove our so you have our user here, but let's remove all this code in here. And now what we have, we just want to read. It's the other way around. So we want to read a JSON string, which is we already saved it into a file. We want to read our JSON string, and we want to output it back into the into our user struct. The way that we can do that is by using our Marshal. And this is very similar to the Marshal one, it's just the other way around. So you pass the byte slice, which is a string representation of your JSON object, JSON string, and then you pass a pointer to a type, which is the data to which the JSON is going to be decoded into. So a Marshal passes JSON encoded data and stores the result in the value pointed to by v, which is the second argument here, which is an empty interface. If v is nil or not a pointer, Marshal returns invalid Unmarshal error. So bear in mind that you always need to pass the pointer to a value, and it also cannot be nil. Marshal uses the inverse of the encodings that Marshal uses, allocating maps, slices, and pointers as necessary with no following additional rules. That's where it says the Unmarshal JSON. The Unmarshal JSON into a value implemented in the Marshal interface. So it follows the same logic as we have seen in the Marshal JSON, and it goes into each type that it finds, and it calls the Unmarshal JSON method. So it's pretty similar to what the Marshal JSON does. It's just the other way around, and it also has an interface which is Unmarshaler, JSON.Unmarshaler, that allows us to specify a custom behavior for parsing JSON. Not only encoding, also parsing JSON. You can have custom behavior there. Okay, so the first thing that we're gonna do now is we are going to so we have JSON string error. We have the we open our out.json, which is our file. So if you just we have a out.json file here, so you will see JSON.out.json, which is the output of what we have done before. So we just want to go back into the original object. So we read the file, we check if there is any error, we read the file. So then JSON string is just a byte slice, JSON bytes. And so now what we want to do is we want to define our struct, our variable, where we want to save the decoded values. So we have user, and then we have a JSON.Unmarshal. We said the JSON.Unmarshal takes a byte slice, which is the JSON, the raw JSON, and takes the pointer to, sorry, the address of the address of the object where we want to store the data into. We check if there is any error. If there is no any error, we just do thump as printf. Sorry, printf. So now what? Now we're just gonna see. I think everything is what we need. So we when we open the file, obviously we have a OS.file. We need to read the file altogether. So we need to get the bytes out of the file. We could use, there are a bunch of things that we could use. There is io-util.readFile, which is what we're going to use, or we can use, now that we already opened the file, read all, which is io-reader byte and error. So we're going to use this. And we're going to see in a moment why we're going to use this. So we have the file here, the JSON bytes error io-util read all JSON bytes, sorry, file. If there is any error, we check if there is any error. Then I think just import the JSON, the io-util. Now we see that it cannot parse the time that we have just specified. So we know that we have the 2020 11/22, which is the time that we have parsed here, because we use the custom encoder. When we encoded it, we said that we just want a minimal time. But the Unmarshal JSON for the time uses the old format, is the original one that we have seen before, which is the long one. So we need to do the same thing that we have done. We need to do the same thing that we have done with the marshaler interface as well as with the Unmarshal interface. So we said go.json unmarshaler. So the Unmarshal interface, as we said, has one method with Unmarshal JSON, takes a byte slice and returns an error, and that's what is going to be used by the JSON decoder when it converts back from JSON to a Go type. When it converts back the type, but you need to then specify that to our custom time. So for custom time, we have defined the Marshal JSON, but we haven't defined the Unmarshal JSON. So just to keep in mind that if you then format it in a particular way, then you need to tell the JSON decoder how to then format it back, how to parse it back, Unmarshal JSON. So this just returns an error. So we need to parse the time, which is the time error. This is time.parse, layout, v, which is the time. So now the time is just a string, and the string has double quotes, and then it has the time inside. So we need to first remove the double quotes, and then we can parse the string. So that's a bit fiddly. That's why sometimes when we work with Marshal and Marshal JSON, you just have to bear in mind how the string is represented, or the values are represented in JSON, and so on. So this string just removes the first and the last occurrences of the double quotes from v, which is a byte slice, so you need to convert to string v, and then parses the layout, and then if the error is not nil, return nil. So this should do. What it does is just time.parse, so it's just a utility function that takes a layout, then takes a string and attempts to create a time attempts to create a time from the string using the layout, and it set that into the c.time, which is our time, our custom time, and then we don't need this because the referencing is already happening when we do c.time. Just check. Obviously this is not JSON, so it's not going to parse. But still we have seen that this is now showing up as we expected it to show. So go run main.go. So we have the JSON string, and we're trying to decode the JSON string into our struct, and the struct is as follows: the name Bob, age 20, city, name London, GDP, population. Created that is parsing the time as we expected. Obviously you're losing the time, the hour, minute, and hours, and seconds, and all of that, because we haven't saved it into we didn't save it into the actual JSON, but that's what we're getting back. So we are already parsing the thing back. And the GDP is 0 because we haven't saved the GDP back. So yeah, so that's pretty much the marshalling and unmarshalling. So I just wanted to go through quickly the decoder, which is a buffered unmarshaler. It's just the same thing. It's just using a buffer, and using the IO reader, it's much more memory efficient. So when you have an IO reader and an IO writer, and you want to decode JSON or encode JSON starting from starting from an IO reader or going into an IO writer, what you could use instead of the marshaler, you can use the JSON encoder and JSON decoder. And that will allow you to use buffered encoding and buffered decoding. That means that in only a certain number of bytes at a time are loading into memory. So it's not, now when you do read, all the file is loaded into memory. Obviously in our case, so let's first go into our example. So what we're gonna do is we're gonna do JSON new decoder, decoder takes an IO reader, which is F, and decode takes the same parameters, v interface, and an error. Yeah, because obviously you don't have the JSON bytes, so you just have your value that you want to decode. So pretty similar to what we have done before. Now what we do, we just create a new decoder from an IO reader. So use an IO reader, which is a file stream, is a data stream, and then it returns a JSON decoder. The JSON decoder, it is a JSON decoder, which is a buffer decoder, which means that only loads a certain amount of bytes in memory. So it doesn't use a lot of memory, as opposed to if you were to load a huge file using IOUT read all. In this case, it's not going to make a huge difference because the file is just a few bytes long, so it's going to be buffered anyway. I mean, it's going to be in memory, all in memory anyway. But if your out.json would be hundreds of thousands of lines of JSON, then using the new decoder would be more efficient because the buffer size would be much smaller. So it will load only up a certain number of bytes in memory at a time, and so it would go through the IO reader, and it would decode the IO reader just a certain number of bytes at a time instead of loading everything into memory. And that's why the new decoder using the code is much more efficient. Same goes for when you want to write the output into a file. You would use the JSON encoder. So now, for example, what you could do is you do the coding from the JSON file, and then we could do the re-encoding again. So we could do, for example, if, or rather we could do the f. I forgot to close the file here. Actually, also have to close the file as well. So just bear in mind, this is not production code. It's just to show the the functioning of the JSON encoding and decoding. So obviously, there is a bunch of things that you have to make sure, the close and the panic and all of that. So as we also did the JSON decoder, using the decoder like this, we could also do the same thing, but we could encode and write into a file using the encoder instead of using the marshaller. So that will not load everything into memory. How would you do that? Well, you just have a file2 and an error os.open file, which is out2.json, and this would be os.create. Write only, create, and then permissions. If error is not nil. So once we have the new file, once you have the new file, you know that the F2 is a IO writer, implements an IO writer. It's because the file always implements IO writer and IO reader. If you open it in write mode, obviously. So if you open it in read mode and you attempt to write, and it's going to fail. Defer f2.close, close, and then if error JSON new encoder this time, so it's similar to the other one, f2 encode u, which is our value. You are not using it anymore. So this is coming from the original file, and it's showing back the values with our JSON decoder using the buffer decoder. And the out2.json is also showing us the final encoded JSON. So it's re-encoding it back to JSON, just using the JSON encoder this time. So you can also check the documentation of that just to learn more about it. JSON.new encoder or new decoder, it's the same. It does a new encoder that writes to W, encoder, encoder. An encoder writes JSON values to an output stream. A decoder reads and decodes JSON values from an input stream. So it's pretty much the same. It's just one is used for buffered encoding, one is used for buffered decoding. So there's also a gotcha when you're working with big files or big streams of data. If you can just use the JSON encoder, JSON decoder, it's going to be much more memory efficient. And I think that's everything for today. Thanks for watching, and catch you on the next one. Cheers.